Today's lesson is carrying a polygon onto itself. Do you guys remember this Martin Gardner thing?
Yeah.
So remember when we did a 180-degree rotation?
And it stayed the same.
It stayed the same. It carried onto itself. So the idea of carrying onto means you can't even realize that something changed. And there's two ways to make that happen. Rotation sometimes works and flipping sometimes works, and it just depends on this idea called symmetry. So we're going to do an activity together in your Chromebook. So you're going to go to your Chromebook first, and hopefully this will work. And if not, we'll do it all up at the board together. You're going to go and find an activity called rotational and reflectional symmetry in the Google Classroom, and it should take you to something called Amplify. You might need to log in with your Google. Let's see if it works. And don't get carried away. We can rotate and reflect. So rotations are first. So here we are. We're on slide 2. So everybody should get there. Okay, so you have, what shape is this? What shape do you got?
A hexagon.
Hexagon. So it has how many sides? 6. 6 has what letter in it? Is the third letter? X. And hexagon also has the letter X. That's how you remember it, right? Okay, great. So how many times in the hexagon is the exact same position while it's in the circle? So can you guys actually turn it or no?
Yeah, you gotta press the rotate button.
Oh, is there a rotate button? Look at, woo, oh, look at that. So how many times does it go around? Try it. And it's going to do it itself. You just got to wait for it. Is it? Wow, that's so weird. It has 6 sides and it has 6 rotations, right? Does everybody agree with that? Now, this is a very special hexagon because all the angles are the same and all the sides are the same. It's called a regular hexagon. All right, put in the 6, say submit, and go. I'm going to take you to the next slide. Boing. All right. What do you guys think for this equilateral triangle? There should be a drag. You should be able to drag this little dot. Okay, how many degrees do you have to rotate it to get it to land on top of itself? And that's called mapping onto.
360.
So 360 is can definitely do it, but what is that the shortest?
It's every 120.
Well, okay. Why would it be 120? What can you do with your numbers?
I can tell you.
Sure.
So it's a 3-sided shape.
Yep.
Triangle.
Mm-hmm.
So if you divide 360 degrees, which is in a full rotation, by the 3 sides of the triangle, you would get 120.
Very good. So it's 120. Let's go to the next one. So now, don't shout it out. Let's see if everybody can figure it out. Here is a square. What is the smallest number of degrees to rotate it to map onto itself? Yeah, very good.
Thank you.
So then what other degrees would work?
Any other number that's divisible by 90.
So if 90 is the smallest, if we skip count by 90s, we get 90,
180,
180, and 270, and 360. That's all you get. All right, so now we're going to slide 5. Whoops, where's the thing? Student. Rotational symmetry. So here is our regular hexagon. 360 divided by what? To get the first one. 6, because there's 6 sides. So 360 divided by 6 is 60, right? Okay, so that's going to be that. Is it asking the follow-up question about could you skip count by 60s and keep getting to all of them?
Yeah.
Okay. So let's go. We're going to go on to number 6. Are you guys ready?
Yes.
Okay, here we go. Play now. Everybody, just pause. Don't yell out things. Play with that trapezoid. It's an isosceles trapezoid. When does it map onto itself? Does 90 degrees work? No. Does 180 degrees work? No. So even though this is a really cool shape, how far around do you have to go to get it to map onto itself?
360 degrees.
360, right? You have to go all the way around. And does that make sense to everybody? So even though it's a cool shape, and the thing is, rectangles and parallelograms are going to bite us, so be careful. Here we go. Here's our rectangle. We're going on to slide 7. You ready?
Wait, I'm just entering this.
Okay, I'll go back. I went back to 6.
Yeah, sorry, you want to explain your thinking. So
You have to explain your thinking?
yeah.
We're doing this together. We're okay.
Active has rotational symmetry, and then it says you have to explain your thinking.
Don't worry about it. Do you guys, we're doing it together, but I want you to, the reason why I want you on your screen so you can manipulate. Are you guys all trying the manipulation? Yeah? Okay. Let's go to the next one because this is the one I need. These two are the important ones. Play with the rectangle. It has 4 sides, but does 90 degrees work? No. Does 180 degrees work?
Yes.
Okay. And then it would just be 180 and 360.
Yep.
Okay? So be careful. Okay? Are you ready for the next one? Don't worry about the thing. Are you good? Parallelogram. So it's a beautiful shape, but try it. Does 90 degrees work? No. Does 180 work?
Yes.
Okay. So when you're asked a question without any pictures, can you draw your own pictures and turn your paper? Okay. So I want you to think about that. All right. So are you guys ready to go to the next one? Yes? Okay, here we go. So now let's look at this shape. This shape is called a nonagon. What? How many sides does a nonagon have? 9. Okay. So do you guys remember what 8 sides is? Octagon, right? Okay. Pentagon.
7. Oh wait.
Pentagon. 5. And then decagon.
10.
10, okay? So 10 is like decade. All right, so now this is not one we normally play with, but what are you going to do to get your angle of degree of rotation? So you can play with it. Why is it 40 though?
Because of how many sides it is.
Okay, so and what's the math problem we're doing? Luca.
So since there are 9 sides,
Yep.
you divide 360 by 9 and you get 40.
Very good. That's exactly right. And then we skip count by 40s, right? Okay, great. We're going to the next page. You ready?
Yes.
Here we go. So this is similar to what's already in your note page. You guys are not recording this right now. But the thing we're doing is we're always doing this 360 divided by the number of sides. And it has to be what's called a regular shape. Otherwise, we don't get, like a parallelogram is a quadrilateral, but it's not like a square. Square has all 4 equal sides, all 4 equal angles, right? So you have to be careful when it's not all 4 same, or like all the same equal sides, all the same equal angles. We have to play around with that. Okay, so we're going to summarize that in just a minute. Now, here we go. This is our first sort. Let's see if you can do it. Okay, so now this is a hot mess on your page. Can everybody find the 90-degree angle rotation words? Do you see those? Just slide it over here to the left to make your life easier. Put 180 in the center and put 120 at the end. So then try to sort. And the 100, what you have to do to get it to attach is you kind of sit it on top. And do you see how it highlights? It can attach. So you're trying to sort them by their angles of rotation. And I think that's all of them. I don't know if I need to go full screen or not. Let me double check. You might have to go full screen to see everything. Oh, nope, it's just those. So I always think the 120s are the easiest to do. Do you see? So be careful. I don't know, the diamond is kind of crazy, right? I think this is, no, that's not 90. Uh-oh.
Yeah.
I have a boo-boo, don't I?
And then that one goes to 180.
And then this one goes to 180, right?
Yeah.
Does this make sense, everybody?
Yes, it does.
Okay, cool. It might have told you if you're wrong, but you can hopefully keep going. I'm going to get out of here. Oh, wait, check your card sort. Oh, did everybody get a full green bar?
Mine's full.
Did anybody else get a full green bar? Does anybody need me to go back to the answers?
Oh, it's because this.
Okay, so fix your answer. and then go to the bar.
It's not letting me put it in.
Does anybody need help with that, like
Oh,
technology-wise?
Put it in now.
Good?
Yeah.
Okay. All right, so don't worry about it if you didn't get it. Once again, this is just an activity to expose us to this idea. Okay, we need to move on to, all right, we're on to lines of symmetry. So did you guys jump to page 13 with me?
Yeah.
Okay, cool. So on reflection, I don't think I'll take the job at the mirror factory.
Ha ha.
You get the joke?
Yeah.
Here we go. Okay, cool. But beware, not all shapes can be folded. Okay, here we go. Boing. Okay, so reflectional symmetry. A figure has reflectional symmetry if the figure can be mapped onto itself by reflection over a line. So how do you guys feel about the fact that I can fold the heart in half here and that's going to map onto itself?
Yeah.
Does that work?
Yeah.
Does anybody want more explanation or a video right now? Let's keep exploring. Let's keep exploring. Here we go. Next one. Boing. Okay. To play around with this, folks, this is what your goal is. You move, so say I go ahead and hit reflect right now. Do you see how it flips it, but it doesn't map onto? Right? So then I'm going to move the 2 points to make my line vertical. Do you see that? And now I'm going to try reflecting again. Does it carry on to itself? Okay, so you guys play around. Check off the ones that you think work. If you don't understand what it's asking you to look at, let me know. And then you can hit submit. But the nice thing is here you can actually reflect and play with it. Does anybody need assistance? Does it make sense what to do, Brandon? Yeah. And if it's too hard to manipulate, you can always ask me to demonstrate. Come on, there we go. What do you guys think about these diagonals, right? Does it work to reflect it over a diagonal?
No.
No. So that is where they will try to get you. So what's the only thing that worked? Vertical and horizontal. Submit. Okay, that works. Great. Let's go to the next slide. Okay, here we go. This trapezoid. Is there anything that's going to work for the trapezoid? That didn't work.
Oh, I know
So
one.
horizontal doesn't work.
Vertical works.
Okay, let's try it out. So vertical through the center point, right? So that works. Do these diagonals work?
No.
No. And so it's good to just try one just so you can see what it does. Ew, right? It doesn't work. Okay, so sometimes you only get one and it's the vertical one that works, right? So we can hit submit and yay. Okay, am I going too fast?
No.
Okay, go to the next one. What about the square?
That's gotta be
All of them.
You think it's going to be all of them?
Yes, it's equilateral.
So
Square.
it's equilateral and it's equiangular, or you could say it's a regular polygon. It's a good vocab word. A regular polygon. So do our diagonals finally work?
Yes.
Yes. So notice it's going from vertex to vertex, and then when you're doing these horizontal or vertical ones, it's midpoint to midpoint. Yes? Okay? Okay. I'm going to go to the next one. Ew, rhombuses are weird. What about the rhombus? Play around. Do you like these sides?
For like diagonal ones.
No. No. But what about, so the ones that are diagonal,
Those ones are nice.
so do the diagonals work?
Yeah.
Yeah. So I actually wish they had the rhombus turned a little bit more like a parallelogram, like how we like to see parallelograms, because the rectangle, it was like through the midpoints of the sides, right? But the rhombus, it's the diagonals. Diagonals go from corner opposite vertex to opposite vertex. Okay, are we good to go forward?
Wait.
Nope, wait, I'm waiting.
That's not correct.
Okay, so does,
Wait, diagonal does not work.
Yes, the diagonals are correct.
What? Okay, wait. But are you going through, so a reflection, vertical line through the center, a diagonal. And then this one is a diagonal. So then it says through parallel. So it's at, like if are we good?
Yeah, it's right.
So the idea of being parallel to a side and reflecting does not work. Okay? Okay. Are we now ready to go?
Yes.
Okay to go? Okay. So now this is once again the parallelogram. Can you flip the parallelogram any way and have it land on itself?
Yes. Wait, no.
No, that's what you get. That's why we're here. So try a diagonal. Did it work?
No.
So try some midpoints. Do they work?
None of them work.
I don't think none of them work.
None of them work.
So I want to press the none button so that should work correct.
So what's interesting is that parallelogram has it's such a great shape, but it has very little carry on to properties, okay? So just beware of that. All right, let's keep going. Is there more? I can't remember how much more it is. Oh, then this is kind of like the summary, right? So, is there more after this? I know I'm forcing mixed practice. Now we're gonna skip. Okay, I'm worried about time. So did you guys get enough of an exploration that helps with the visual? Okay, good. You can close your Chromebooks and go to your note packet because the note packet does not have a lot of notes for you to take. It's mostly just a summary of what we just did. So we're on page what? Here we go. Ooh, okay. We're on page 10. Here we go. Okay. So a couple of things for us to write down. So you have to have some sort of symmetry to be able to carry on to itself. We need to know our polygon names. So 6-sided is a hexagon, right? Oh, wait, that's right. White ink will not work. So a hexagon is 6. You guys know octagon. You guys were good with that. Pentagon. Penta. And then if you think about gon always being the prefix, ouch. A pentagon is 5. That's also the name of the fancy building in Washington, D.C. for like the military.
Yeah.
Okay. A nonagon is 9.
What's on the 7 side?
It can be 2 different ones. They usually do septagon if they're going to. So September comes before October. So and there used to be, with the Greeks, I believe, the Greeks or the Romans, used to be a 10-month calendar, right? So decade is 10. And if you go back, November, October, September. So decagon is 10.
And what's for 6?
Hexagon. And then octopus is for octagon. These 8 arms. Okay, and then this word is thrown into questions, and it means that all the sides and all the angles are congruent. So both of these are pentagons, right? But this one is the regular pentagon. So the regular pentagon will have rotational symmetry through the center, and then it will also have where you can fold it, right? And lines of symmetry. Okay, so then basically the next of these pages is just a summary. So here we go. Our rotational symmetry is done by taking, and it's here in a sentence, but you might want to write it off to the side. We take 360 degrees and divide it by the number of sides. And that works for regular polygons. So I underline the word regular. And then basically for shapes that are not regular, like a rectangle or a parallelogram, you just have to kind of play with it, right? 180 works. Let's see what works. And then we saw that the trapezoid had no rotational symmetry. The other thing is, remember, you can skip count forward with the numbers. So sometimes it asks what's the minimum degrees, and sometimes it'll ask like what degrees works to carry on to. So the only answer that might be there is 288. Okay, I'm ready to turn the page. Beep. Okay, and then this is your summary for line symmetry or reflectional symmetry. So a line of symmetry can just be there on a shape floating in space, but they can also throw it on a coordinate plane, which means they might say, does it have reflectional symmetry over the line y equals x or an axis? You know what I mean? So you just have to then plot your lines on the grid, which means we're going to rely on our calculators to help us do some of that. Okay. Then just kind of this goes through here. Like isosceles does have its one line of symmetry. Scalene would have no lines of symmetry. Equilateral would have 3. So a regular polygon is going to have the same as the number of sides, but you can see for our rectangle, even though it has 4 sides, it only has 2 lines. We saw that for the rhombus, etc. And then this is where we saw that some of those things don't work, and so it's hard to visualize that without actually practicing folding paper. So just be really careful. Folding a rectangle on a diagonal, folding a parallelogram on diagonal, poo-poo, yuck, yuck, doesn't work. Okay? So our parallelogram has like no lines of symmetry. So there it is, no lines of symmetry, none. And then for the rotation, it only had 180, right? 180 and 360. So although parallelograms are the bomb, woo, they stink for this. Okay? So we're going to do 4 Regents questions together, and then you have 1 more Regents question to do with me, and then you have, I think, 5 or 6 I'm going to give you for homework. Okay? So pretty easy class. Here we go. Regents questions. So let's kind of look at the different things they might give you and how to best get it right. So first one, it says in the diagram below, the square is graphed in the coordinate plane. Does everybody agree that's a square? Yep. Then it says a reflection over which line does not carry the square onto itself. And then there's these 4 equations. What is our strategy, my friends? What do we need to do to have a really successful time at this? Should we draw the lines? Yes. Okay, so that means we might need to go to our calculator to find some of them. Or does anybody know where some of these lines fall? Anybody? Does anybody know where the line x equals 5 is? Is that vertical or horizontal? Okay, so if we don't know, yeah, friends. So this is why I really want you to turn on your calculators. I'm going to add a page. I'm going to add a graph. This is like the easiest question. Just pick up your calculator. It'll make your life worth it. You hit the delete key to get rid of f of x. And then we're going to choose relation. And then the equation was x equals 5. Where is it? It's vertical at 5. Does anybody need me to repeat that process? Okay, so I'm going to go back here to my question. I have too many things open. And I'm going to draw on a line. I'm going to use the color green. And it's this line right here. Is that going to work? If I take this point and reflect it, it's not going to go anywhere. What's going to happen to this point if I reflect it? Isn't it going to go way to the other side? Okay, so first of all, do we have our answer? Yes, but we are going to keep trying. Where's the line y equals 2 now that we just remembered? If x's are vertical, where are y's going to go?
Horizontal.
And so horizontal through 2. Let's find 2. 1, 2. There it is. So what do you notice about this line? Does it cut the shape in half?
Yes, it does.
Okay. The line y equals x. Use your straight edge. It's the line that goes from corner to corner, right? So use your straight edge and draw that line in. Use your straight edge. Draw that line in. Woo. Right? Does that one work? Okay, so then there's this last line. X plus y equals 4. Let's talk about some strategies for this. Could you just put this in your calculator to see where it goes? Sure. So if I go to my calculator, how do I get the line back? What key do I hit to get back the thing I need? Tab. Very good. So if I hit tab and type in x plus y equals 4. And now it's the downhill one. Oh, wait. So can you guys tell that this is at 1, 2, 3, 4? And the 1, 2, 3, 4. So if I find those 2 points, I go to drawing and I go 1, 2, 3, 4 and 1, 2, 3, 4. Oh, it's that diagonal. It's not a nice line on the grid, but it certainly is a nice line for, right, for the square. So can anybody tell me the equation of the last line? What would be the last good line? What's the last good line? It's not there as part of the question.
Y equals negative x. Right? 4.
So I didn't ask it well. Is there a fourth line of reflection here?
Oh, yeah.
Yeah, so it's the vertical one, right? It's the line x equals 2. One last thing about this equation. Could you make it a y equals?
Yes.
Okay, what would you do to make it y equals?
Wait, 4?
For choice 4.
Yeah, you make it y equals negative x plus 4.
Okay, so you subtract x on each side,
Yes.
and you get y equals negative x plus 4, which means it has a y-intercept of 4 and a slope of,
Negative 1.
yeah, negative 1. So don't forget those algebra skills. But that's why we also rely on our calculator skills, because we can sometimes forget things, right?
Yeah.
All right, let's try the second question. Are we good?
Yeah.
Okay, it says, which rotation about its center will carry a regular decagon onto itself? So our key word is decagon. What number do we need to know?
10.
10. What number are we going to need? Because what's all the way around a circle?
360.
So 360 divided by 10.
36.
Okay. And let's just take a pause right there. That answer is not there. So that means it's going to be a multiple of 36. So you have a couple options on your calculator. You can, and let me just, get out of here. Control page, add a calculator.
I gotta tell you away.
Well, what would you do?
I would say 36. I just put a 36x.
You do an equation with y equals 36x?
Yeah.
Yep, you could totally do that and look at your table. You could just go, hey, is 54 divisible by 36? Nope. Is 162 divisible by 36? Nope. Is 198 divisible by 36?
No.
Nope. Oh my gosh. Is 252 divisible by 36?
Yes.
Yes. And it's on the 7th turn. Okay? So some kids just choose to skip count, so they would literally write down 36, 72, 108, 144, and continue forward, right? And just skip count until they get the right number. All right. 2 more. Let's go to the top of this one. Okay, so now here, instead of having a shape on a grid, we have a shape floating in space, right? So it says the figure below shows a rhombus. Okay, we haven't talked a lot about rhombuses, but the special thing about rhombuses is all 4 sides are congruent. So this side is equal to that side is equal to that side is equal to that side. So it's like a square, but does not have the right angles of a square. All right. So now it says, which transformation would not, so make sure you read carefully, not carry the rhombus onto itself? So reflection over the short diagonal.
No, that would do it. So it would.
So that works. So what about the long diagonal then?
No, that's the same way.
That works, right? So these are, so a lot of times when I'm answering these types of questions, I'll put okay after the ones I've already tried. Just like when I'm doing true, false, I do all 4 before I actually circle the one I'm guaranteed to be like, that's my answer. That's good strategy for multiple choice. What about a clockwise rotation of 90 degrees?
No.
Is 90-degree rotation going to work?
No.
No, that's when it turned it pointing up, right? It was kind of weird. But will 180 be okay?
Yes.
Yes. So, and this is when you would turn your test and turn your paper. Sometimes I redraw things. My favorite thing to do for a rhombus is actually draw it this way. So we all know about a diamond on a deck of cards. So I always draw a rhombus this way so I can really see the following. Can you guys see that this is a right angle? Right? Those diagonals form to make 4 right triangles that are all the same. So I always redraw my rhombus if it's not presented this way. Okay, so that's like the diamond in a deck of cards. I don't know, like it's kind of, you don't want to make it a kite because kite has short and then long. So do the best you can to like kind of make it that. Sometimes I draw the diagonals first to make it easier. So I'll draw a long diagonal and the short diagonal. Okay. All right, one more at the end. Which regular polygon has a minimum, so there's an important word, a minimum rotation of 36 degrees about its center to carry it onto itself? And I think we have the answer because we just did it on the other side. What's it going to be?
A decagon.
A decagon. So once again, nonagon has how many sides?
9.
9. So that would be 360 divided by 9 is 40, right? What about an octagon? How many sides for an octagon? 8. So 360 divided by 8 is 45 degrees. It's really good to see these like low numbers. Our pentagon is kind of a weird one because it's just divisible by 5, right? And that's going to be 72 degrees, and multiples of 72. So 144, which is a fairly nice number because it's 12 squared. We like that number, right?
Yeah.
Okay, so those are your 4 examples, and I have one more that I want to do with you, and then you're on your own for the last ones on the back. So we're just doing the front. You're going to see that it's got like the same thing 4 times on the front. What? This rocket crazy.
What do you mean by wait, what do you mean the one?
I'm giving you a homework assignment right now.
I'm sorry.
And so you're all good. You did a nice job. Okay. Can you pass one back to Adeline for me? So one for you. There you go. There we go. Whoops, one for you. Ladies, I'm coming. And one for you. Okay, so the one on the front, I actually just repeated the picture 4 times. I'm trying to emphasize that you really want to try all 4 choices. And sometimes when you get too much on your paper, it gets a little monotonous, right? So that's another reason to use pencil. But here we have our question. It says that the square is graphed, and then which transformation would not, isn't it amazing how many times they use the word not, would not carry onto the square. Now, I can't guarantee it's always that way. But here we go. So reflection over the y-axis. I'm going to draw the y-axis. And I'm just going to wait for a second. And this one over here, I'm going to do choice 2, reflection over the x-axis. Okay, rotation 180 degrees about the point 1, 0. Where is the point 1, 0? Does it turn out to be this point right there in the center of the square? So this is choice C, or choice 3. This was choice 2. This was choice 1. So here's our last equation. Y equals x minus 1. So the -1 is the y-intercept, right? So we go to -1 and plot a point. And our slope is what? What's the slope in y equals x minus 1? So remember y equals mx plus b. So what invisible number is in front of the 1? A 1. So the slope is 1, which is 1 over 1. So you go rise 1, run 1, plot a point. Rise 1, run 1, plot a point. Rise 1, run 1, plot a point. Can you go backwards? Sure. Down 1, back 1, plot a point. And then, so this line is the what of the square? What do we call a line that goes from vertex to vertex? Diagonal. It's a vocab word we need to go, a diagonal. So this is choice 4. So don't blindly just pick an answer. Make sure you try out the 4 choices. Which one is the correct choice? Choice 1. Because if we were to actually reflect it, our reflection would look like that, wouldn't it? Right? Anything that's 1 away on this side, it's 1 on the opposite side. Anything that's 3 away on this side becomes 3 away on the other side. So choice 1 does not reflect over, or does not carry the square onto itself. All right, that's your lesson. It's not very exciting, but it is a great Regents question. You have 6 to do on back, I think. All right, and the pictures are not repeated. So be careful. Look at your notes about some of the special shapes. You still have 8 minutes.